Hello everyone, I'm Dr. Kokida. I'm from the Department of Biochemistry from the Oxford College of Science. I'm here to talk about the topic climate change. So, so what are the take home from this lecture? The end of this lecture, the students will try to understand what is climate. Normally, everyone will listen the word weather. So we'll try to differentiate between the weather and climate. And apart from that, they'll try to understand what are the factors that can influence climate and what observation in climate change research has led to a pile up of data which we can conclude something happening in the climate change and what corrective measures has been put forward to come back the climate change to its normal phase and how India is trying to mutilate climate change. So I request all the students to pause at this point and then have a written answer what they will say the definition of a climate. And hope it is done. Now, what is the difference between a climate and a weather? Weather is a real-time measurement and it is taken at that particular day-to-day point, like what would be the temperature change, what is the humidity change at a specific place, what could be the precipitation activity. But in relation to the weather, climate is an average measurement. For example, at Oxford College of Science, what is the weather today is described by what is the temperature today, is it raining or not, will there be any change in the wind patterns, etc. But climate will be over the period of time, over a long time, what is the changes happening. With the same parameters like what is the changes happening in the temperature, or humidity, or was there a snow time, etc. This climate change is generally recorded over the range of 30 years. What and all changes are happening. So, in a definition, climate is defined as a statistical weather information that describes the variation of weather at a given place for a specified interval. And the study of this climate pattern is called climatology. And changes in weather is day-to-day changes, changes in the state of atmosphere, and it is a very short-term variation. And the study of weather is meteorology. So now we see on what the climate is dependent on. The primary most thing, everything for everyone it comes to mind is the atmosphere. Yes, the atmosphere, in atmosphere, what and all, the structure of the atmosphere, the radiation coming into the atmosphere, the wind pattern changing will influence the uh, whole atmospheric parameters. In addition to that, the Earth's rotation also influences the climate change. Apart from this, there are certain Earth component systems like the oceans, the cryosphere, the terrestrial biosphere, the Earth's crust and mantle are important. The biosphere, the biotic component will come into the major influence on climate change, but I have put the biotic factors in terms of the geological cycles which will influence the climate. For example, hydrological cycle or the carbon cycle, the way the oxygen is being utilized or new species of oxygen is being created by influence of biotic factors. So we'll take up one after the other. So first I have chosen to talk about Earth's rotation. Earth is not a perfect sphere. So that makes the way the Earth rotates also influence the wind pattern. For example, Earth's axis is tilted by 24 degrees. When it is tilted by 24 degrees, the center axis to 45 degrees, that is the Greenland, the changes in the Greenland directly affect the way the rotation is happening. So the Earth is not perfectly revolving, it wobbles. Due to this wobbling in the precision, the climate also changes. Suppose there are more ice forming in the one place, that will increase the perfection of precision. Precision is the revolution around its own axis. So when there is melting of ice, That will lead to reduction in density, and that again increases the wobbling. That will affect the Earth's climate. And also the radiation coming from the sun directly influences the climate, because we always tell there is global warming. So the amount of radiation which falls into the sun, that is the energy budget of the Earth, is changing because of the climate change. For example, the total energy coming from the sun towards Earth is 342 watts per centimeter square, watts per meter square. Sorry. So out of that, our atmospheric clouds and all, 77 watts per meter square is reflected back. On the Earth's surface, 30 watts per meter square is reflected back. But our Earth also absorbs certain heat, and then it gives out heat. Like for example, our plants, they absorb certain radiation, and then the other surfaces on the Earth, like it can be ocean surface only, that also helps in reflecting back the sun's energy rays. So the incoming radiation is a short wave radiation, and outgoing radiation is a long wave radiation. So if our atmosphere is filled with certain components which are absorbing this long wave radiation and does not allow them to cross to the atmosphere, then that will also lead to the climate change. That we'll see in next few slides, like what are those components which will be increased in the atmosphere that will lead to climate change. So next I'll come to what is atmosphere. Anything above the Earth's crust, as we go on high in latitude, that will become the Earth's atmosphere. The vertical atmosphere has different phases, and the maximum, what we say atmosphere, the presence of many gases, which is very important for our presence on this Earth, is in the initial phase of the atmosphere. That means initial 10 to 12 kilometers of the atmosphere, which we call as troposphere, is very important, because 75% of the Earth's atmosphere is present in the troposphere. And this troposphere is also important, and there is, during in this different parts of the Earth's atmosphere, there are changes in temperature. Like the troposphere has an ambient temperature of 15 degrees at the bottom, like on the ground, and then as we go on higher and higher, the temperature decreases. And from 16 kilometers to above, like 20 to 25 kilometers, is the tropopause, where the temperature does not change, and that also some people put into troposphere only. Next to that is the stratosphere, the important layer, where you can see the ozone, that starts from 16 kilometers above the Earth to 50 kilometers, and that is where if some gas, there is no proper mixing of the gases in stratosphere, and for example, if some airplane or jet releases carbon dioxide, it takes very long time for it to be fixed or removed from that place. So that part is the important layer. So above stratosphere is a stratopause that starts from 50 kilometer to 55 kilometers, and above that is the mesosphere, where the temperature again starts reducing, and that is also an important place where you can the temp. Okay, where we can see the shooting of star blaze in mesosphere. Next to that is the thermosphere, which ranges from 90 kilometers to 640 kilometers, and this is an important area of the atmosphere, because the temperature is very low, and then there is lot of radiation coming into the atmosphere, because as I told, in the stratosphere there is ozone layer which blocks the UV rays and protects the Earth, but that is not there in the thermosphere, and the temperature is very high, which releases the gases out into the exosphere. Exosphere is the farthest layer of the Earth's atmosphere. So broadly we can say the Earth's atmosphere layers into troposphere, stratosphere, mesosphere, thermosphere and exosphere. So troposphere is the important region of the atmosphere which contains all the vital gases. So let us go briefly into the chemical composition of air. Chemical composition of air, as we all know, we think oxygen will be the major percentage. No, oxygen is just 21% of the atmosphere. The highest is the nitrogen. Nitrogen is very inert gas and it's non-reactive. So followed by that is argon, water, carbon dioxide, helium, methane, krypton, hydrogen, nitrogen dioxide, and ozone. So out of this, water, carbon dioxide, methane, nitrous oxide, and ozone are important greenhouse gases. They are important at the specified level. For example, carbon dioxide at 300 ppm is very important for maintenance on temperature. As I told before, there is long radiation which will be reflected back from the Earth's surface. These gases, the long radiation which is reflected is the IR radiation or the infrared radiation. These gases, like carbon dioxide, they can absorb this radiation and cause little warm in the atmosphere. So that is the reason why the Earth's surface is very apt. Like for example, in Mars, where there is a thin layer of atmosphere, and it is there is low atmospheric pressure, and there is no evidence of life. In the same way, in Venus, if you compare, there is a thick layer of atmosphere, but it is 95% filled with carbon dioxide, which is freeze the Venus planet, and that is also not inhabitable. But in our planet, there is an apt combination of components which can absorb a required amount of radiation, cause little warmth. That is why the sea surfaces are all not freeze, and they are habitable for the uh, growth of life. And as I told, the greenhouse effect is increasing of these gases, is leading to what is called as global temperature increase or global warming. If we consider the use, for example, there are lot of sectors which increase these greenhouse gases. For example, energy supply sector or agriculture or the building, the paints on the building also release these greenhouse gases. That increase has led to increase in the temperature of the earth, which is now we call it as global warming. For example, it is reported in Climate Action and Support Trends in 2019 that the past 2 to 3 years there is 0.5% increase in the global temperature. So the main culprit is the carbon dioxide, which is in the atmosphere, which increases the temperature. As in this graph, you can see there is logarithmic increase in the level of carbon dioxide. 380 ppm has now, 310 ppm has in 1957 has now increased as reported in July 2019 to 411.7 ppm. All these recordings are made by taking ice cores or by direct measurement. For example, in Moa Lab Observatory, Hawaii. And this increase in the carbon dioxide as is directly influencing the global temperature in this by increasing the radiative forcing component. First, it was estimated that the sun's energy, sun's rays are also responsible for increasing the atmospheric temperature, but as the climate change is the recording average over the past many years, it is seen that radiation has a lesser chance of contributing to global surface temperature increase than these gases. These gases are the main components which are increasing the global temperature. So, apart from this, the climate change can be influenced by changes in the ocean, because 75% of the Earth's surface is made up of oceans, and oceans are responsible for the biotic factors also. They act as a carbon sequestering place where we can utilize that in mitigating climate change. More than that, the cryosphere, the solid water, that is the ice, also are important in the generation of ocean thermohaline circulation. For example, when there is winter, there is complete ice, and as you approach summer, the surface layer of the water becomes little water, and that circulation happens. This whole current is responsible for the polar water, freshwater accumulation. The terrestrial land also is important for helping the climate helping more than helping, it is influencing the climate change. For example, the type of vegetation what we have, that can actually stop the winds and then bring rain, or if there is no vegetation, there is no rainfall, indirectly affecting the increase of surface temperature. The Earth's mantle also is important in influencing the climate change, because the way the surface temperature is changing, because of that the tectonic motion also can change and lead to more volcanoes generation, or there can be a continental drift. Apart from this, including the biotic factors which can influence the temperature, climate change, I have included hydrological cycle, popularly known as water cycle. Now, what is this water cycle? Water cycle is like, I'll start from the base, the ocean which is getting heated up by the sun, evaporates, there is evaporation, and then as the evaporated vapor goes up, there is condensation, and this condensation causes the clouds to form, and the clouds are taken over to the surface of the land, and there is precipitation on the land. So the way the El Nino effect, for example, in uh, okay, in Peruvian coast, there is high heat, and then that causes the vapors to form, and during the vapors goes and condense. As the Australian coast is cooler than the Peruvian coast, there is formation of clouds, and these clouds are carried over by the wind, and that wind, like for example the southwest wind, which carries the clouds to the India, this effect is called El Nino effect. Because of the climate change, there can be severe droughts also. This pattern of precipitation, for example, if there is increase in the temperature, there is no condensation near Australia, that means we are not getting the rain. The El Nino pattern is affected by climate change. The next cycle is the carbon cycle. As I told, carbon dioxide is one of the important greenhouse gas which causes the climate change effect. Carbon cycle, basically it starts, for example, saying I start with photosynthesis. Photosynthesis fixes the carbon dioxide, and that product is eaten by the primary producers. And primary producers, when they die, they decay, and that gives the carbon that again they burning will release the carbon dioxide. There are other pathways. When we are breathing, we release the carbon dioxide, and the more important is the ocean phytoplankton, which can fix the carbon dioxide, and when they die, they go and settle in the bottom of the sea floor, which gives the food for the sea floor animals. So carbon sequestering can be utilized to mutilate the climate change. So till now what I was talking, it was what are the factors which can affect the climate change. So now we'll see what is the reality. So there are various agencies like Intergovernmental Panel on Climate Change, or any national agencies which are monitoring this climate change in all geographical regions across the globe, have put up data to say, like for example, the ocean surface temperature has increased from 2000 to till now by 0.2 degrees, or sea level has increased from 2000 to till now by 0.05 meter. So that is an alarming factor, and also the greenhouse gases have increased. Basically, the carbon dioxide emission is increased. All this by a lot of fossil fuel burning, or fires which are getting in the atmosphere. So this has also, we can observe this by the glacier reductions. For example, here I put up a Switzerland glacier in 1859, and in 2001 there is a lot of decrease in the area of the glaciers. And also the precipitation pattern. This is the 2007 data, where you can see the rains which were supposed to come in the equatorial lines have been changed, and the long day time and short night time have increased, due to which, for example, the cold temperature extreme which we were supposed to have has shifted towards the more hot weather conditions. And because of this more hot weather condition where there was not supposed to be rain, we see heavy precipitation. So climate can vary naturally in response to natural processes such as variation in sun's radiation, the earth orbit around the sun, or the composition of the atmosphere due to volcanic eruptions. So during the last few slides only, I am telling there is impact on the nature. Now it can be in terms in terms of impact towards agriculture, productivity, because there are like in the last slide I told there will be rains in places where it has supposed not to be there. So the agricultural yield from that place will be reduced, and where the agricultural yield was supposed to be there, it is also varied. So indirectly affecting the water resources, human health is affected, and economy is also affected. And there can be generation of more cyclones by intense tropical cyclone activity. So this is a WMO data which tells about lot of how much of the each ecosystem has been damaged. So this mutilate this climate change. There are a lot of policies which have come out. Like for example, UN Framework Convention on Climate Change. They first spoke about the chlorofluorocarbons which has to be reduced, and there were a lot of countries which signed in the treaty, and many more plans have been coming up. So this is a paper which tells about India has been. There are a lot of models which has been created based on the previous accumulated average data to predict what could be the temperature changes in India in this 21st century. So yeah, we can see they have divided into many sectors in this paper, and based on anthropologic aerosols or based on just on greenhouse gases. For example, this see based on greenhouse gases, there can be the increase in the surface temperature in North India very much. And then apart from that, based on land usage or solar radiation, we can see variations in Indian temperature also. Uh, by signing the treaties and applying the corrective measures, India has improved the condition by a little bit. Last year it was ranked 14. This year climate change performance index has ranked India into 11th place because we have reduced the greenhouse gases, and then use of renewable energies, and hope there will be further. So in our library, there are few books on climate change by Prabha Shastri, and climate change and effects on human health by Pani Kumar. Enough copies are there. People who want to know further about this can refer. Thank you.